So this is the second lesson. This is on page 5 of your unit handout. As a warm-up, I'd like to go back to grade 9, maybe even grade 8, depending on who taught you grade 8 math. And I would like to ask everybody to expand this out. We call this FOIL. So I would like you to expand it out and simplify the result. And what you're doing right now is the opposite of factoring. You're taking two binomial factors and you're turning it into a trinomial. Put up your hand when you're done and then put it down. Same thing, continue to, for those of you that haven't finished, when you do get finished, put your hand up and then put it down. Okay, I would say that if you're competent at math, and I know that this is first thing in the morning and I just threw this at you and we haven't been expanding, we've been factoring, but I would say that if you're competent at math, it probably shouldn't take a Math 20-1 student more than 10 or 12 seconds to do this. Like maybe 15, maybe 20, but it's not a time-consuming thing. It's not going to take you 5 minutes to do this. You go first, which is 2x times 4x, which gives you 8 times x squared. Your outer is 1 times 2x, which is 2x. Your inner is negative 3 times 4x, which is negative 12x. And your last is the negative 3 times the 1, which is negative 3. And I just choose, when I FOIL it out to explain things to people, to stack the x's on top of each other, because your next step would be to combine those x terms. And my point is this, because I'm going to teach you how to factor something today that is using a different method than what you were taught in grade 10, which in my mind is a very confusing method. I don't think it's a good method. It shouldn't take you more than about 10 or 12 seconds to FOIL out the product of two binomials. Let's keep that in mind today. So now let's get started on the lesson. We're going to be solving quadratic equations that are similar to the ones we had yesterday, except that the coefficient of the x term will not be 1, and we will not be able to factor that number out because it won't be a common factor. So, for example, solve the following quadratic equation using the method of factoring means we're going to factor this into the product of two binomials. And if the product of the two binomials equals 0, then either of the binomials will equal 0, just like we did yesterday. But yesterday we simply had to look at two numbers that multiplied to give C and added to give B. That does not work here. Okay? Are you with us, Kendra? Just checking. Okay. In grade 10 math, you were taught the following method. This is what it's called, the method of decomposition. How many of you remember that name? So not very many people even remember what it's called. I'm guessing that next to nobody, there might be the odd person, remembers how to do it. Does anybody remember how to factor this using the method of decomposition? This is why I have this conversation with other teachers, particularly grade 10 teachers, and I go, why are we teaching this? It's something that works, but it's this long, complicated process. And in the end, nobody remembers how to do it anyway. So I'm going to show you a method of factoring this. And this, you can, if you want a name for this method, I just call it trial and error. And I'm not meaning to suggest, you can call it guess and check. I'm not meaning to suggest that you're going to just randomly guess two binomials and hope that it works. But what I am saying is, if this is factorable, and until I tell you otherwise, I'm not going to give you ones that aren't factorable and say factor it. I'm not going to try to trick you, okay? If this is factorable, and it is, it will factor into two binomials. Now, if we go back and look at what I asked you to do in this kind of warm-up, and we kind of reverse engineer things here, this is 8x squared because these two items multiply to give 8x squared. So what does that tell us? It tells us that when we start to factor this, I have to put things here and here that are going to multiply to give 6x squared. And by the way, we can also learn from this warm-up that each of those two terms has to contain an x, because your outer product and your inner product have to contain an x. So we would never put, for example, 6 and x squared in those two highlighted spots. There has to be an x in each. Now, we have options, and you don't need to write this down. I would rather you just think about what I'm telling you. You could put 6x and 1x. You could choose those two things to put into the highlighted portions. Or you could choose 2x and 3x. And I'm going to tell you something which would be very helpful with trial and error. It's almost never 1 and the number, if there are other options. It's almost always numbers that are closer together. So, and we could be wrong. That's why it's called trial and error. So, and it's also why you're using an eraser, okay? Or maybe scrap paper. I'm going to say, well, this is 2x, and this is 3x. Let me fix that. I'm going to say that this is 2x and this is 3x. Now, going back to our warm-up, we notice that this last term in our expansion, the negative 3, comes about because of the product of the two constant terms in our binomial, in our binomial. So we had 2x minus 3, and we had 4x plus 1. So we have a constant of negative 3 and a constant of 1, and they multiply to give, in our answer, a constant of negative 3. So what this means is that the two numbers that go here and here have to multiply to give 3. Well, this is easy, actually, because there's only two numbers that multiply to give 3 that are integers, 1 and 3. And don't write anything just yet, because what I'm about to write, I'm going to erase or get rid of. It's got to be 1 and 3. If I put a 1 here and a 3 here, I know that's impossible. You don't know why that's not possible yet, but I'm about to tell you. The reason is, if I put a 3 in the second set of brackets with the 3x, there is now in here a greatest common factor of 3. And when I look at the original expression, there is no greatest common factor of 3. I can't create a new common factor if there wasn't one to begin with. And that tells me, logically speaking, it's got to be this. Okay? Now, I may be wrong. It might not be 3x and 2x. It could be 6x and 1x. But this is why it's called trial and error. And everything that I've done so far and said might take you a minute or so to process on your own. You'd go, well, what do I put here and here? Well, 3x and 2x to get 6x squared. What do I put in the other spots? 1 and 3. Now you do the check part of the guess and check. You start foiling this out. So this is, it could be done on paper, but it's not really necessary. You don't have to show at this level how you get the factored form. So you FOIL it out. You go F-O-I-L. So you go first, 2x times 3x, which is 6x squared. And that makes you happy because we had 6x squared. Honestly, I don't think we need to check that because that's why we put 3x and 2x there, right? but just for completeness sake. The outer is 1 times 2x, which gives me 2x. Inner is 3x times 3, which gives me 9x. And last is 3 times 1, which is 3. Well, the 3 makes me happy because I wanted to get a 3. And then I ask myself, will the outer and inner products come together to give me 11x? Which is what I want. Yes, these two things collectively make me happy as we can be about being successful in math. Okay? Because up here we have 11x, and that means that this is factored. And that whole process is something that you may stumble on the right answer right at the beginning, or you may have to change your choices. So for example, let's say we're done here. So I'm about to change some things, don't write them down. Let's say it didn't occur to you that this is not something you should try. Let's just say you didn't think about that. You would still have the same first and last. Your outer would be 3x times 2x, which is 6x. Your inner would be 1 times 3x, which is 3x. These two cannot come together to give you 11x. So you'd get your eraser out, and you'd erase that 1 and the 3, and you'd try switching them. And if that didn't work, then I guess you'd have to back up and try 6x and 1x instead of 3x and 2x. Which is rare. It would be very, very rare. So let me go back to the proper work. So we've factored it completely. This is our answer. And you know what? Everything else is not necessary at all. Like literally, when you're showing your work in algebra, you just go from that to the factored form. You don't need to explain how you get it, ever. So let's try another one. And my goal here is to probably finish this one, or get it started and have you see if you could finish it. This one is really easy because 2x squared can only be 2x and x. That's it. And 5 can only be 1 and 5. So I just said 1 and 5, and I'm going to write them down in that order. By the way, we're not done with question 1 because we've only factored it. We haven't solved it. We're going to come back to that later. But I want to focus on the factoring right now. If you FOIL that out, does it work? That's the question I'm leaving you with right now. If you FOIL that out, do you get 2x squared plus 11x plus 5? And I suspect most people would just look at it and go, well, yeah, I'm going to get 10x on the outer and 1x in the middle. I get 11x. So we are done. The FOILing out to check doesn't take long. And I'm honest with you when I say I just put 1 and 5 in that order because that's the order they came out of my mouth. Had you done this, your outer would be 2x, your inner would be 5x. Well, I can't get 11x out of 2x and 5x. So it must be this. Now, when we return to class at the end of the day, we still have to solve these. Because, for example, in this question, what we now need to do, so that's not our answer. That's the factored form of the question. We have to take 2x plus 3, make it equal to 0, and solve that equation. And we have to take 3x plus 1 and set that equal to 0 and solve that equation. Right? It's not just factor, it's solve. Here, we're going to have to take 2x plus 1 equals to 0 and x plus 5 equals to 0. And I'm going to stop there. We're going to continue this in period 5 today. Yeah, go ahead, Ariana. Wouldn't what? Either of them. Because if this equals to 0, do you see I'm getting a little bit ahead of myself here that you'll get negative 1 over 2? So that means when negative 1 over 2 is x and you put it in, this factor will be 0, which means the whole equation is 0. Do you agree that this is negative 5? That means if I put negative 5 in for x, this factor is 0, and the whole thing is 0. We do have to include both in our answer. Have a great day, you guys. We'll see you later on this afternoon.